Synthetic division of polynomials. So synthetic division is basically a shortcut for division of polynomials. However, it only works if your divisor is in the form of x minus a number. So that can be x plus a number, x minus something, even x in a fraction. But it has to be linear. If you have a divisor of an x squared or a higher exponent than 1, you cannot use synthetic division. Now, here are the general steps for using synthetic division. However, we're just going to go through an example because sometimes reading the steps is going to be a little bit harder than just walking through it. Now, again, just like long division, it is necessary if you are missing a variable to replace it with a 0. So for example, we have negative x to the third, 4x squared, and then we don't have any x's at all. So we have to actually enter that in ourselves. We have negative x to the third plus 4x squared plus 0x plus 9, all divided by x minus 3. So since the divisor is in the correct format, we can use synthetic division to divide this instead of using long division. Well, with synthetic division, we basically turn our division sign upside down. Now, we only use the coefficients, so that's kind of what makes us a little bit shorter. We're not using all the variables, we're just using the coefficients. So the first one is a negative 1. The second one is a 4. The third coefficient is a 0. That's the one that we replaced or we put in the placeholder. And the final is a 9. So this is what is being divided. Now what you're dividing it by is x minus 3. However, we're going to actually take this little x minus 3 and solve it and get x equals. And so that basically means we're going to have to change this negative into a positive 3. So what you're dividing by on the outside is a 3. So for example, this one here, if you're dividing by x plus 4, you would actually put a negative 4 on the outside. If this is x minus 3, put a plus 3. Since this is x plus a half, you would put a negative 1/2 on the outside. Now for the actual synthetic division. So the first thing we're going to do is drop down the first coefficient. Now the outside will multiply. So we're going to take 3 times negative 1 and put the result back on the inside of my division sign. So 3 times negative 1 makes negative 3. Then, to get another number outside, we're going to add these two together. So 4 plus a negative 3 makes a positive 1. And then we start over. So then we take 3 times 1 and put it on the inside. So 3 times 1 makes 3. And then again, to get the number on the outside, you're going to add these two together. So 0 plus 3 makes 3. And then we do it one more time. We take 3 times 3 and put it on the inside. So 3 times 3 makes 9. And then finally, to get this number on the outside, we add these two together. So 9 plus 9 makes 18. So we have completed the synthetic division process. Now, how do you write the actual quotient of these two polynomials? Well, the last one here is usually inside of a box, and because whatever's the last number is always the remainder. This may be a number or it may be 0, but whatever number is last is always the remainder. Then the other numbers on the left are the coefficients of the leftover variables. So this first one is actually your constant. There's no variable on the first one. This one here, the next will be an x. This one here will be x squared. If there was another variable or coefficient out here, this would be x to the third and x to the fourth and so on. So start with your constant and then incrementally go up by a single exponent every time. So our final answer is going to be a negative 1x squared plus 1x plus 3. And then remember, the remainder is always plus remainder over what it is we divided by, which was x minus 3. And there's our final answer. You could have done this by long division, but this was a lot simpler and a lot shorter to get to the correct answer. Let's look at example 2. We have 3x to the fourth plus x to the third minus 2x squared plus 2x minus 5, all divided by x plus 1. So we are not missing any terms in the numerator portion of our fraction. We have 4, 3, 2, 1, and no x's at all. And so if we start setting up our synthetic division, which we are allowed to use because this is x plus or minus a number. So let's use our synthetic division. Let's set up our backwards division sign. We're going to use 3, 1, -2, 2, and -5. Be sure to carry the correct symbols, the correct signs with your numbers. On the outside, we are using the opposite version of this. So instead of a positive one, we are using -1 on the outside. So start your division. The first one drops down. We have to have something to multiply by. So we're going to take -1 times 3 and put the result on the top. -1 times 3 makes -3. Then to get the new number down below, we're going to add together 1 and -3 to get -2. And the process starts again. -1 times -2 makes +2. And then we add these together to get the number on the bottom, which is a 0. -2 plus 2 makes 0. And the process starts over. -1 times 0 makes 0. And then we add these together. 2 plus 0 makes 2. And the process starts again. -1 times 2 makes 2. And then we add these together, we get -3. So again, the last number is always the remainder. Then this number is the constant. This one is your x. This one is your x squared. This one is your x to the third. So when you write your answer, it'll be 3x to the third minus 2x squared plus 0x plus 2, then the remainder, plus the remainder, which is -3, divided by what we divided by in the beginning, which is x plus 1. However, since this is 0x, I don't even really need that in my answer. So our answer is simply 3x to the third minus 2x squared plus 2 plus a -3 over x plus 1. I want you to pause the video and try example 3 on your own using synthetic division. Remember, replace any missing variables with a 0 coefficient in the front. And here's what you should have had for example number 3. You should have replaced x squared with a 0, and then drop the first one, multiplied, added, multiplied, added, multiplied, added. There's the remainder, constant, x and x squared. Now, where is synthetic division used besides just a shortcut for long division? So we can actually use synthetic division to determine if something is a linear factor of a polynomial or not. So here is the math theory. So basically, if x plus or minus something is a factor of some random polynomial, then that means if I divide the polynomial by whatever it is I'm trying to decide is the factor, the remainder is going to be 0. If the remainder is 0, it is a factor, and so maybe we can write that down. Remainder is 0. Remainder is 0, that means yes factor. If remainder is not 0, no factor. Is not 0, that means it's not a factor. And so let's try it on example number 4. So it's asking you, is x plus 5 a factor of 3x squared plus 2x minus 5? So we're going to use synthetic division to decide. So my inside numbers will be a 3, a 2, and a -5 because we're not missing any variables. We have x squared, we have x, and we have no x's. And then the outside number is going to be a -5. It's always opposite of whatever this is. And so we start our synthetic division. -5 times 3 makes -15. -15 plus makes -13. -5 times -13 makes a positive 65. And -5 plus 65 is 60. So here is the remainder. So because the remainder is not 0, we can say that no, x plus 5 is not a factor because the remainder was not 0. So I want you to pause the video and try number 5. See if x minus 7 is a factor of this polynomial, 4x to the third minus 26x squared minus 37x plus 161. Go ahead and pause the video, try it out. And here is your solution for example 5. Since the remainder was in fact a 0, that means yes, x minus 7 is a factor of this polynomial here. Now, where else can it be used? So you can also use synthetic division to evaluate a polynomial. So basically, the old way we used to evaluate was by plugging in our x value for every x and then simplifying using order of operations. With the synthetic division, basically we can say that the remainder is the evaluated version of the polynomial with whatever x is. So if we look at number 6, we're going to do 6 and 7, which are extremely similar with each other. So evaluate f of x equals 5x to the third minus x squared plus 13x plus 29 when x is equal to negative 4 by using substitution. So this is the old way of doing it. So before we would have y equals 5 times x is negative 4 to the third power minus x again, which is negative 4 squared, plus 13 times x again, which is negative 4, plus 29. And we were going to use order operations to simplify this down. Well, negative 4 to the third is a negative 64, minus negative 4 squared is 16, plus 13 times negative 4, which I can go ahead and multiply. 13 times negative 4 makes a negative 52, plus 29. And then we can keep going. I know that 5 times negative 64 is going to give us negative 320 minus 16 minus 52 plus 29. Combine all those numbers together and we get a y value of negative 359. So this is the old way that we would have to use evaluation. We would have to take x and plug it into every x in the polynomial and then use substitution. Now, with third exponents of 3, that's not too bad. But what if I had an exponent of 6? And I had x to the 6th, x to the 5th, x to the 4th, x to the 3rd, and so on. This process can get very lengthy very quickly. So let's use synthetic division instead. Now you'll notice you should end up with the exact same answer. So if we use synthetic division on the inside, we're going to have a 5, a negative 1, a 13, and a 29. Now, this time, on the outside, we're keeping negative 4 the way it is. And the reason why is, you see how it has x is equal to negative 4, not x minus 4. So if it is x minus a number, then we use the opposite. However, if it's x equals the number, we use the same. Basically, this is already set up for us. Nothing to change, we're good to go. Now let's start our division. So this is a 5, negative 4 times 5 is negative 20. This makes negative 21. Negative 4 times negative 21 is 84. 84 plus 13 will make 97. 97 times negative 4 is negative 388. And negative 388 plus 29 makes negative 359. So remember, this is the remainder. And the remainder is what this should be when you evaluate the polynomial. And if we look, we have the same answer as we did when we evaluated in the traditional sense. So it doesn't really matter which method you use. However, synthetic division does move a little bit quicker, and we don't have to worry about the squares and the cubes and possibly to the 4th power. So the way we usually write this answer is we say f of negative 4. So what this is the y value evaluated at negative 4 is equal to negative 359. That's usually how the answer is written. The y value evaluated at negative 4 is equal to negative 359. So pause the video, try example 8, using synthetic division. This should have been your answer for example number 8.